So next speak, okay, Zhang Li, the Vice President of Technology at Tencent PCG. I think he will guide us through the world of large languages, model-based autonomous agents and their applications. Zhang, okay.
大家下午好，今天我这个 topic 相对比较技术一点。
My topic is quite detailed and technical, which means it's LLM-based intelligent agent and its applications. As we all know, if you're familiar with AI, and before the last April, this fundamental monitor training tweeting went viral. But after that, when AI agent went viral extremely quickly, I want to share with you, especially from what's beginning and to now, many agents from AI, some good thoughts and their applications, and hopefully it will inspire you.
So today, this is my agenda. So first is, what is agent? And we just look at the second one. The definition was more clearer, and saying that autonomous agent has several features. First, it's a sensed environment. We need to sense environment. Second, it should have a planning of its own agenda and does not human intervention. Thirdly, it should be able to act on the environment. These are the three elements of the agent. This is a very clear definition. And now let's take a look at another example. So one company is called a Hyperride. It provides a personal assistant agent. So I want to book a flight. I need to sense your time and what is your destination. And this agent will give you a plan. For instance, it shows on the right, it will do something, which is an agenda setting. And only by doing this action can it do the work, which is the action of the booking.
就是
Why do we need agents? And because we know, actually, if you know about the LLM, we understand LLM better. We know there was some problems with LLM, and then so far away from AGI. So these are the three things you know. And first is hallucination. Second is limited knowledge. And third is context capacity limitations, because our memory will be limited to 2K, 4K, or 8K. This is very limited. But if we want to perform an AGI, we need to use a lot of domain knowledge. For instance, I want to realize a ticket booking function. I want to know what are the valuable tickets, and what are the airlines that I can use for me to fly me from A to B. This is not something that LLM can do. So why is that AGI provides and plays a vital role? Because it can enhance the LLM. And agent implementation, I did a picture drawing so people understand what kind of thing we need. First, we need to have the planning, and lower right, we need to have a memory. We also need to fast track the access and obtainment of the fast memory. So obviously, this gives you an idea. And also, there was the inter-agent collaboration. We needed to have the capacity for communication.
我们再看一下我这里边总。
And then let's take a look at the general framework I summarized. I just divided into 4 parts, 4 components. First is called cognition, which is the cognitive capacity, including the reasoning, the planning, and the memory. The second one is perception, and then there was the action, and improves, which is really the online action and our capacity to interact and engage with reality. A true robot should be able to operate on the true object. Then we have the collaboration, multi-agent and human agent collaboration, and we will dig deeper in this aspect. So in for the recent half a year, uh, industrially or academically, we see something interesting. For instance, React uh, is really the most close observation or realization, and it means that they have designed device and thoughts, then do the action. After the action, there will be the environmental observation, and then this reflection will be incorporated into the next round of action. Then there was a suggested action in the second round. Then we got the observation for environment. It's really a popular framework. This is also a very good solution, which is called reflection. And my idea of it is that it can be used in lots of places, not just as a self-learning with autonomous reflection and observation. I try to summarize with another LLM, but I got a inquiry, and give me an answer. Then I use a evaluation model to see whether this answer satisfies the customer's query need, what is good and what is bad, what is mistaken in this message. And I input it into the LM for a second iteration. And for instance, in this product, we found that this LLM is not so as efficiently, responding. We can show that there will be we can adjust the response of LLM in a brighter fashion. There was also the self-ask. Self-ask means that it can make sure that LLM can do something. I mean, it's easy to understand. If I give it some, for instance, who lives longer, A or B? Then we ask the large LLM to ask questions. A, how long does A live, and how long does A B live? And after knowing A and B longevity, they try to compare which lives longer or who lives longer. It's like a sort of divide and conquer. For reasoning, I want to say I want to fast track things here, and I'd like to show you several things. And you may have know it. First is the traditional idea. Let's give you an input into the LM, then the result comes out. And COT means that we try to think step by step. So the COT is really a branch of steps. Then there was also the SC. SC means we make sure that the LLM is asked to implement through multiple pathways. Then we do the voting to decide which plan is a majority vote result. For example, I have a request, and there will be three answers. Then we do the majority word, and so one got the 18 votes, which is largest volume on vote, and we'll find it will be able to do things very quickly and improve efficiency and precision. There was also TOT, the tree of thoughts, and TOT has learned from the best of practice, and because TOT means that it tries all the time. First, it goes this channel. If this pathway is not working, I do the backtrack. It's really an exploring of the pathways, and that is the idea of TOT. Then I do the memory. So there was a lot of content, so I just to speak of the two important things. First is the summarizing memory, and the method used is really the vector retrieval, or called the RAG, which is retrieval augmented generation. And the idea is that I make sure that domain knowledge is put into the vector base. When my user is there, I try to generate a vector inquiry and try to search the external memory. Then you put it in a short-term memory, and then generate the eventual answer. So if whether it was memory bank or SCM, the whole idea is based on the vector database, and also it's a long-term memory sharing. Let's take a look at an example, which is a symbolic memory. And there's a paper on that, which is ChatDB. ChatDB does not use the work database, it uses a very good ER database. ER database means that it turns the natural language into SQL and make changes. And the good thing about it is that the work database, when we do the work database, it generates the worker. And when we retrieve, we use the proximity searches. That is, when it comes to different, the answer may be different for the same vector database. But symbolic is coming from symbolism, which means the symbolic memory is an accurate idea. Obviously, it has other strengths as when we do this multi-hop reasoning, we make sure it would not create any added deviations. And yeah, just look at these two examples. If we use traditional methods, we'll use the vector retrieval. It includes not just the data, and when we calculate, we cannot calculate very accurately. If we use the symbolic memory, on the one side, we can use C-code computing. We can also get a very clear answer and precise answer. These are the two different memory mechanism, long-term memories. Now let's take a look at the tool, and that is really a main element of agent. There are several methods. First, how can we make sure that LLM can understand the tool? One typical method is tool formula, which is we fine-tune an agent to use API. Where I do the make sure the LLM can be fine-tuned, right, by a lot of language feeding, but it does not scale up. If there is new function coming up, I needed to prepare the language again, fine tune this whole thing. It's not like the ChatGPT. It just needed to register. Therefore, it is another pathway. And of course, it has its own strengths and weaknesses. What I want to say is really the fine tuning, which is called tool it's done by the Tsinghua University of China. And it has a lot of good optimization. First, it uses a lot of API, and it has to use the GPT to tag the orders. Therefore, it has generated a lot of a huge corpuses, and therefore the thing is called the door bench, and it works with Llama to create something which is called a Pro Llama. It has something good in it. Firstly, it is very diverse, and secondly, it is very diverse. And thirdly, because when it's training itself, we prepare the different scenarios of use. So therefore, it can use a lot of instruments. And this is the amazing side of this paper. This has a very good practical values. How do we use the tools? It has a very typical case. The first is the WebGPT. From WebGPT to WebGRM, it is a very efficient method. Cannot go to detail due to time limit. Last but not least, let's take a look at the making tool. And there was also a paper called something which called LATM. The core idea is with the GPT-4, we try to create a very good solution. And we make sure that it can automatically generate these tools. And then we use a chip model, GPT 3.5, for instance. We use this thing to execute this tool. So the string of thoughts is really amazing. It can realize one-time use and multi-time reasoning. We can lower the load, and the GPT-4 can do the unit testing and do the verification to do wrapping of. Therefore, the instrument or tools and quality can be ensured. And there was also the agent application, which is something all people pay attention to. I actually summarized this year's Smart to till now agent application. And I use different things to say, okay, is it a vertical application or a journal application? So let's take a look at the general application. Obviously, you know the RGP to GPT. And if you do that, RGPT and how the GPT are put together as a discussion. RGPT is iterating GPT agent, and it can create a creation agent. which means by promotion, I look at the next step, and as it points to the next step, I look at the store data and the context, then I try to break down. It's really a progressive agent. Let's take a look at Hugging GPT. Hugging GPT is different. When it got a mission, and make sure that it can make the plan first. Yes, and in this way, I make sure that this action can be finished. That's why Hugging GPT, we say, has a lot of problems and may just fall into a death trap, or it can get more and more dispersed. So therefore, HackGPT can really avoid that by pre-planning. We also have something which is called HoloGPT, and which is really innovative solution. It simulates human thinking and human reflection, and also it simulates the human idea for copying and also reflection. It has several highlights. The first is automatic, subjective or proactive learning, and because that makes sure because when human beings are evolving themselves, they evolve by learning from mistakes. For instance, we memorize our mistakes in the documents. When we execute cinema mission, we will look at these documents, avoid these mistakes. So OLGPT has done something similar, and it has something which is called no library. It tries to store the previous mistakes and try to ask the expert to offer a tagging or right answer.
This is mimicking how human is proactively evolving. So we know that C is like majority vote, right? Depends on which one vote the most. But Ola GPT offers you a new capability. It's not about just voting. We put the answers, regardless of being true or false, together, stack them together to another LLM. Yeah, based on the output from different pathways, we will have access to a new answer. So from the result of experiment against a variety of the scenarios, it works more than that of vote with even more innovations. Your habits of thinking will be summarized. Horizontal one and a metaphor-based. And for example, how you will push maybe from the beginning to the end, or as a logic backward induction. And also you will also have a variety of the divide and rule and the divide and conquer, etc. What about the data agent? For data agent is that agent will be able to do analysis and even painting or drawing by itself. This is called data copilot. It has some key thoughts available based on the data source we have from the self-request as the mechanism. It's like a self-instruct or self-act. It will generate the interface library. It will generate a lot of API and may have the data operations. When it is online, we will receive maybe a request from users, and we will also to identify the retrieval-related interface. It will put that into the properties, and then it will help to address that task. It's like the Talk GPT. It will also split up into variety of the steps to address the tasks. Next, about education agent, they are not nothing. It's not something new actually, and it is leveraging voice as a input and performing task planning. It's like a pre-scheduled process. When it comes to game, agent is very important for Voyage in last May from like NVIDIA. That's the agent model. It used an agent to play Minecraft as the game. It's a lifelong learning game agent. It's a very interesting concept. It has maintained a skill library. It's like the so-called function calling. And number two, it has proactive learning. It's lifelong learning. It's active learning. It keeps its iteration. It's like all GPT, very similar to that. And when you try it at the very first time, maybe there will be some exceptions. When you play the games, when you move left, it may tell you, oh, it's wrong. It will give a reminder. The direction is not correct. It will be saved this exception into the update. And the next time during the iteration, it will skip this part. I may not turn left. I may not turn right. It keeps learning. It is active one. It's like a note library from Ola GPT. Next, about a robot agent is the Facebook and the CMU embodied agent. The key point is to especially leveraging the natural language, so your action is not an online tools. It is the physical items managed by a robotic arm. The overall thought is exactly the same. Multi-agent is something very classic by the Stanford town. It's the first creation of a virtual environment for multiple intelligent agents with cafe, its apartment, different PCs, 25 PC, each of which has different character, a persona, and a works, and there's a setting. A very unique social network relationship is set up. Yeah, for each agent, how it is executed is differently. Yeah, it has its own reasoning capability. It's a Stanford town. I forgot the name of that. Yeah, I really like how it looks like. Yeah, I remember there was a TV episode. It's the West World. I remember it's exactly similar. This is from evaluation, in which there's an article of agent bench, which is the first benchmark designed to evaluate the LLM as the agent, retrieval the database, and how to have the bash command. Online shopping, they are used to just determine to rate that. What about the challenges and the prospects we have? Yeah, when it comes to this concept, agent address many of the challenges of the LLM, but it has exists some own issues by itself. Yeah, we also tried a variety of the agent in the past year. We executed some of the projects with our experience. Yeah, we believe first is about the prompt robustness. I don't know the Chinese actually. When you are talking about the execution of agent depends on LLM. The key is about your prompt. Yeah, from different prompt, if you change the word, actually they generated the subtask may vary so much from each other, and including efficiency. And that means sometimes it's not very well feasible because it consumed really a lot of the resources. One action may involve a variety of the other the commands, instructions, and whether it aligns with a human's preference. If you book the tickets, you want to have direct flight, but the agent may pick up maybe a multi-jump one, and this is very challenging. And also, for agent remains has great prospects. Apart from QA, right, question and answer, you need to use that. And we're talking about Q&A, right? Quora. If you address the questions, you do need the agent. Otherwise, without the agent, you may have run into many property issues, challenges. Yeah, thanks to the time limitation, that's the end of my presentation. Thank you. Great.
Us a whole landscape on larger language models. A very professional technical guy. Okay.